again, welcome to you. I want to say this presentation about introduction to innovative food technologies for quality improvement and shelf life of foods. So, as you know, the describing and explaining of innovative technologies impact on food production and production in this world, and the nutritional value of foods, nutritional composition and drinks, and food safety and preservation also. New foods, fortified foods, nutraceutical foods and drinks, nanotechnological foods, and edible anti-cancer foods. So, the new technologies in the world depends on, driven by, and the knowledge and the new techniques gained from research investigations, attempts to increase efficiency, reduce environmental of production, also competition between food companies. Also consumer demands is important for us. So, what is the importance in the meaning? Environmental sustainability, and so dietary and health needs and consumer demands also important. Farming and agricultural capacity for biotechnological considerations, new crops, nanotechnological products is important. So, fourth one, the usability of new techniques and technologies for food improving and developing, for food safety, and for nutraceutical foods and edible anti-cancer agents. So, what is the importance in environmental sustainability? So, it is important to say that challenges, alterations, sustainable, affordable food supply and demands, stability in food supplies, achieving global access to food and ending hunger is important. Also, reducing the impacts of food production on the world's environmental systems. So, controlled innovative technologies are necessary immediately. So, another one, dietary needs and consumer demands. I say before, medical and nutritional science academicians want this. So, there is more knowledge available on nutrition and dietary needs. This includes information about presentative nutrition, preventative nutrition, and the true of life. So this creates a demand for new products in the marketplace, So it is important for the controlled innovative technologies are necessary, are demandable. So another one, third one, forming an agricultural capacity. I want to say again, that availability of new techniques is important, but for biotechnology, for genetic research provides opportunity to control cell metabolism and breeding. So this makes it possible for developers to meet more specific requirements, etc., to increase a specific nutrient in a food. So innovative technologies are necessary in this point. Another one, last one, consumer demands. Less additives is important, and high nutritional value is demanding, and high quality, less thermal demand, and good sensory properties of foods and drinks, and also safe products is important. So thereby, food manufacturing designed for better food safety and quality. Okay, what is the strategies in this point, in the global point for food processors? Firstly, we have to develop premium food products, then long-lasting foods without any, addition, without any chemicals. So convenience foods, minimally processed foods, and ready-to-cook meal or ready-to-eat foods, ready-to-eat drinks, and low fat food, low carbohydrate, low sugar, or any reduced sugar. So specialties in foods. It's important section, specialties in foods, because includes many sub-varieties in this point. So for health treatments, for anti-cancer support, for kids, for military, for pregnant, for sportmen. So a lot of subcategories may be in the specialties in foods. So what is the emerging technologies in this point? So non-thermal and thermal. So what is the non-thermal technologies in these years? High peristaltic pressure, pulse electric fields, ultrasound, ultraviolet irradiation called plasma, dense fast carbon dioxide, ozone, and chemicals. And then what's the thermal? Microwave, radio frequency, ohmic heating, and induction heating. So, what they do for us, what they do for the consumers. One is shelf life extension. Another one, innovative fresh products and unwanted or reduced constituents, sugar or any other salt. So clean label products. Another one, unwanted enzyme inactivation. Another one, firstly one, pathogen inactivation. And food safety, What is the high pressure processing? High pressure processing carried out around the room temperature is the non-thermal process. So inactivates bacterial cells, inactivates yeast, molds, and unwanted enzymes without the use of heat, and then having a minimal effect on sensory quality and nutritional quality of food, and also uses water as a medium transmitter, and then 300 to 700 to pressure. So useful in the retaining the nutritional quality of foods after processing also. So in this point to now, toxigenic compounds, antioxidant activity, and phenols has not been extensively studied in more complicated food matrices. The scientists did some pathogenic problems, food safety, and other things, etc., and the shelf life of foods. But no toxigenic compounds, antioxidant activity, and also phenols has not been extensively studied in the more complicated food matrices. So, what is the high pressure processing in food technology general meaning? So, first the inactivation microorganisms in enzymes, enhancing the efficiency of unit operations and modifications, as you know. And microorganisms and enzymes inactivate, but enhancing efficiency is the different issue. So it is important for the food quality and food improving. So extraction enhancing is firstly important, and another one, emulsification in lipid containing and foods, and homogenization also, etc. Another one, modification section, color, antioxidative profile, bioactive profile, including bioactive lipids, bioactive phenolics, bioactive components in the food matrices. Also polysaccharide modification, sugar, complex sugar modification is also important by the high pressure processing. So, ultrasound technology. US is also emerging technology applied to impart positive effects in the food processing, in mass transfer, food preservation, and manipulation of texture and food analysis. It travels through a medium like any sound wave, resulting in a series in the compression and rarefaction. So, the attractive forces between molecules in a liquid phase, which subsequently leads to the formation of cavitation bubble. Yeah, it studies the with cavitation bubble. The collapse of each cavitation bubble acts as a hot spot which generates energy to increase the temperature and pressure up to 4000 Kelvin and 1000 atm respectively. So, what is the meaning? Energy generated from waves of the 2 million or more vibrations for sound. High frequency or diagnostic is important, 2 to 10 megahertz, and the low frequency or power, 20 to 100 kilohertz, leases and inactivated cells, also cavitation forming. So, variables to control includes temperature control, ultrasonic amplitude control, the time treatment control, another one, cycle control. So, if the name is sonication, it is ultrasound. If the name is thermosonication, US plus heat, as you show. Monothermosonication name shows the US plus heat and pressure also. Most frequently utilizing of ultrasound. What is this? Ultrasonic extraction of phenolic compounds and phenolic pigments, anthocyanins, beta-cyanin, beta-xanthin from plant tissues, and extraction of lipids, proteins from plant seeds such as soybean, cell membrane permeabilization of fruits, and ultrasonic processing of fruit juices, sauces, and dairies, and ultrasonic processing for improving stability of dispersions, and also microbial and enzyme inactivation is another application of ultrasound in the food processing. So, with US, not now and to now, toxigenic compounds, antioxidant activity, and phenols has not been extensively studied in more complicated food matrices also as high pressure processing studies. So, limited studies we have. And general meaning, we have to say that inactivation microorganisms and enzymes, okay, and also efficiency of unit operations includes ultrasound assistant extraction, ultrasound assistant drying, ultrasound assistant osmotic dehydration, ultrasound assisted filtration, and ultrasound assistant freezing, and also emulsification in lipid containing foods, and then homogenization in lipid containing foods, and cutting in the lipid containing foods is necessary for this point. But in the modifications, same as the high pressure processing, because color, antioxidant, bioactive polysaccharide modifications are also same with HHP processing. So in this point, we looked at two technology. So ultrasound technology is more higher, extensive, complications for the food sciences than high pressure processing. So, case studies. I want to see any case studies we have. It is important results for us because there is no data concerning in this point. This is the first data. So, first one, black and green table olives and high pressure processing studies. With high pressure processing, we did the total phenolics, major polyphenols, hydroxytyrosol, and the oleuropein, antioxidant activity, microbial quality, and mycotoxin, citrinin, and ochratoxin, mycotoxin in black and green table olive fruits. So, in the HHP processing results, we found total phenolics increasing 2.2 to 2.5. So after the HHP processing, good results for us. And phenolic hydroxytyrosol in olives increased on average 0.8 to 2 fold, whereas oleuropein decreased on average. It is important for us because oleuropein is bitterness compound. So in the companies, bitterness must be decreased by the sodium hydroxide. So we did by HHP processing. So it is safety processing for us. So non-chemical and also free chemical for unbitterness technology. So antioxidant activity values also varied from 17 to 29 millimole ferric per gram, 100 gram for control samples. So also twofold. Okay. In the HHP applications, when it comes to toxigenic compounds, they were antioxidant components and also wanted components for us, but now unwanted components of the olives. So in the HHP applicated olives, total mold was reduced 90% at 25 centigrade, and then the reduced 100% wholly at 4 centigrade. So total aerobic mesophilic bacterial load also was eliminated. So citrinin citrinin. What is the citrinin? Citrinin is the mold in the surface of the olive tongues. So citrinin load also was reduced 64 to 100% at 35 centigrade after the fermentation temperature. So especially 1 ppb and less citrinin contamination in table olives degraded as 100 percent. As you show, blue one is control and the green is after HHP, pink standard citrinin. So after the HHP processing, wholly eliminated. So for the good technology for olive sector. As you show, so citrinin and ochratoxin compound is together in the same system, and retention times is near. We eliminated also all of them. Case 2. Case 2 with Washington State University I studied. Firstly, high pressure effects on total phenolics, major polyphenols, procyanidin B1, catechin and antioxidant activity, microbial quality in grape pomaces. And grape pomaces was collected from Turkey, and Alicante Boucher, Merlot, Öküz Gözü, Kalecik Karası, Boğazkere, Unique Blend, Cabernet Sauvignon, Emir Şira, Narince. For after the wine processing, any pomace. Pomace is discarding in the sector. So we evaluated the pomace also in this point. So we used the 500 megapascal 30 minutes high pressure in the Washington State HHP, and also we we formed in the our university now this apparatus. In HHP treated pomace samples and antioxidant activity, total phenolic levels increased due to the extraction capacity rised. So catechin concentration also increased in HHP treated and ultrasound treated samples. Microbial stability was highly preserved in HHP treated samples also, as you show. It is stated that catechin, epicatechin and procyanidin dimers and trimers in grape skin and sin, that in the seed of the grape, it had been determined B1 dimer is dominant in grape skin, and more while it was detected catechin level was 4-fold more than epicatechin amount in the grape skin. So, total phenolics and antioxidant activity increasing, and microbial quality of grape pomaces is stabilized. So, many molds and yeast they decreased and also eliminated from the system. So, as you see, standard chromatogram catechin and B1. So catechin and pro B1 in Alicante Boucher, as you see, this is the same line. Another one is Alicante Boucher 300 megapascal. You say, if the we increase the megapascal, this component concentration increasing. So, as you see, 500 megapascal, catechin component is decreased, but procyanidin one increased, because procyanidin B1 includes catechin units. So, catechin units is decreasing by HHP processing, and then procyanidin B1 is increasing with catechin units. So by the increased megapascals also, as you see. With HHP application of pomaces, total mold and yeast load were reduced more than 95, and antioxidant activity increased 1.22 to 198 fold after HHP processing. So total phenolics also increased about 2-fold. So catechin phenolic increased about 2-fold. Procyanidin phenolic decreased about 1.5-fold, we may say. So, another same study, huckleberry ice cream. In the United States, Washington State area, huckleberry is grown in all area. So it's good, berry. So and includes many bioactive phenolic compounds also. And also they produce from huckleberry ice cream, huckleberry sweet extra, etc. So in the university system, we also produce the huckleberry ice cream also. In HHP treated huckleberry ice creams, antioxidant activity and total phenolic levels increased. Due to the extraction capability also raised, especially quercetin levels highly increased and microbial stability was highly increased, highly preserved by HHP treated samples. As you see, standard chromatogram, this one, last one is quercetin. Quercetin is the phenolic compounds, is the flavanol type of, phenolics. Phenolics, includes many area, many divisions, 9 divisions. One of the divisions is quercetin, belongs to flavanols. So this first chromatograms belongs to procyanidin B1 and catechin. Third chromatogram belongs to quercetin. So as you see, after the HHP processing tradition, we increased the quercetin many high because quercetin is important for any other antioxidative treatments. So after this processing, we gained higher concentrations of the quercetin. So and also procyanidin B1 increased, as I see before, another black pumas studies. So case studies on US continue, and yes, we're gonna go now. Ultrasound studies we have to look. We have Alistic astoterestris. What is this? It's a spore-forming rod-shaped organism with a central subterminal and terminal oval spore, and grows at pH values ranging from 2.5 to 6.5 and temperature of the 25 to 60 centigrade. This is acidophilic, this is thermophilic, so this is the different bacteria, non-pathogen, but problem bacteria for the fruit juice industry. So, Acidoterestris is an important sporulage organism of acidic foods because its spores are able to germinate and grow in highly acidic environments and produce guaiacol, which causes medicinal or antiseptic of flowers. It gives different flowers to, fruit juices, medicinal flowers. It is not good flowers, it's antiseptical flowers. So this compound, guaiacol, may be monitoring in the, by the H processing, high pressure processing, and also any techniques. In the fruit juices, where this from coming? So, ferulic acid, 4-vinyl guaiacol and vanillin compounds in the apple juice or orange juice. So after the effect of the Alistic acidoterestris component, microorganisms, to transforming to vanillic acid and then guaiacol. But problem Alistic stimulation is forming to these compounds. This is the subcompounds, vanillic acid, vanillyl alcohol, and methoxyhydroxyquinone. But final compound, guaiacol, unwanted compound for us. The emergency of juice-associated outbreaks. What is the problem for this point? According to the Juice Hazards Analysis and Critical Control Point, HACCP, and Regulation 2001, and by U.S. Food and Drug Administration, FDA, juice processors include in their HACCP plan measures to provide at least 5 log reduction in the pertinent pathogens most likely to occur. So, the juice HACCP regulation only applies to pathogens. There is no regulation for controlling juice spoilage in this point. You sure? So it's necessary for the juice and the beverage industry to take measure and ensure the quality of their products. And also in Turkey, in Europe, in Spain, in Germany, also there is no regulations in this point. So in America also there is no regulation. But fruit juice processors may do according to normal pathogen elimination system. So 5-log reduction in the pertinent pathogens, they say. So if we gain the 5-log reduction, it is okay. All of the microorganisms eliminated, we are relieved. So we have to look 5-log point in this point. So in the Europe also must be controlled, but in USA started now. So we started US effects and apple juice control in the Dimes company in Turkey also. Ultrasound processing FS, Dimes company in Izmir. We are living in Manisa and Izmir, so our company. So with ultrasonic treatments, about 60% and 9% of the Alisticlobacillus azoteresis cells were inactivated after treating the apple juice with 300 WV ultrasound for 30 minutes. Our conditions. 30 minutes is okay. Yeah, pasteurization processing 60 centigrade. It is a little bit pasteurization, but also ultrasound processing. So percent 100 in percent 100 juice, it will be good technology. So the lowest W at 36 minutes was found when using 600 watt. The alterations of sugar level, no change, acidity, no change, hazen, no change, and the juice and browning were not affected the juice quality. So we used the 20 kilohertz in the system, and amplitude was 0.4. So it is the good technology, and it is first applied conditions in also our country and also in Europe. Because Dimes companies, any other branch in Europe also now is applying these conditions. So another case study, we have to look Alisticlobacillus azoteresis and ultrasound. Sorry about that. This is writing the same. Another system, extraction yield improvement by ultrasound. For example, gingerol. We studied the gingerol. The ginger, active components, active phenolics in ginger. So gingerol formula here. So after the supercritical extraction compound, after the with ultrasound, extraction capacity increased. Beta-carotene, polyphenol, gingerol study in different solvents also we applied. So after the ultrasound processing, beta-carotene, 8%, 8 to 25, 20 to 25%, increased. But depends on the solvent also. We use aqueous solvent, yield increasing 8 to 25. When we use ethyl acetate, also 25-20 between. So in this point, polyphenols and gingerol also was detected. So and generally we found the yield increasing at the last stage of the extraction by ultrasonic processing. Another case study concerning the oily nuts and ultrasound study. So we used also in oily products. What is this? Almond, in the pistachio, in the peanut, in the hazelnut. So we used specific conditions for for each nut also. In the microbiological quality of nuts, we use the ambient temperature and 24 kilohertz, but also solvent is different. For lipids of nuts and pests, we used the same kilohertz, but also ambient and solvent difference. And also when it comes to phenolics and nuts and pests, also we used different solvent, but the same process conditions. It is the same one is processing conditions and duration time for us. In the same duration time, in the same processing conditions, just only changing, altering the solvent, we got it the ultrasound applicable NUT results. So, what is the total lipid value after processing? Total lipid decreased after ultrasound treatment in the nut pests. Because in the industry, nut pest is important. Generally, pests, is manufactured from nuts, is macerating, and so with ultrasound, the destruction of the cell walls facilitates the pressing and thereby reduce the residual oil or fat in the pressing cake. So, total lipid decreased after ultrasound treatment. And what is the total phenolic studied nuts? This is a different study also, different results also. After the old processing, averagely, increasing in total phenolics. The use of ultrasound assisted extraction. What is the meaning? What do for nuts? I say it is enhanced mass transfer rates, increases cell permeability, and increases the extraction capacity of phenolic constituents, and the higher levels of bioactive compounds are preserved by ultrasound assistant extraction. So, average 12% increasing in total phenolics. So, this is the different study also. Minor bioactive lutein and xanthophyll of studied nuts in the pistachio. For only pistachio, lutein xanthophyll increased about twofold, 1.8-fold, because it is important as a percent, 73% increasing in lutein xanthophyll. And lutein is important for eyes, and it is a carotenoid. So by the ultrasound processing, pistachio carotenoid increasing, in the lutein carotenoid increasing. So, as you see in the chromatogram, lutein, zeaxanthin, and cantaxanthin, you know that this one zea, this one lutein, this one canta, but in this point, one is very higher in the sample chromatogram. So here, pistachio oil, ultrasound assistant extraction, pistachio oil, lutein component. So lutein 73% increased after the ultrasound processing effect. So another one, cyclopyozonic acid, mycotoxin, and cheese study. So, cyclopyozonic acid is a mycotoxin that occurs in homogenized and fermented foods, in dairy foods, in nuts. This is a different mycotoxin. Generally mycotoxins, aflatoxin, ochratoxin, and etc. That zearalenone. But now is the uncommon, unknown mycotoxins also in our life. Firstly, I say before, citrulline in table olives, but also mycotoxin in cheeses. So it is important also in nuts. So we in our system, after the ultrasound processing, cottage cheese in another süzme cheese, you say, and white cheese, another white cheese is the same. We used for this, for two cheeses. So, as you see, after the our conditions, no mycotoxin cyclopyozonic acid could be found in the system. But firstly, little one is, just a second, here, sorry, yes, concentration 5.25 before, and then now 0. White cheese concentration in 0.93, and after the ultrasound processing, no any other cyclopyozonic acid in the system. So after the US, firstly 5.3 nanogram per milliliter, then 0, and then for white cheese 0.9, then 0. So another system, another study we have, coconut oil, fatty acid profile and ultrasound. In the coconut, we use together all area in milk or any other drinks. So coconut includes generally, not fatty acids, but these fatty acids, not two double, one double, fatty acids. So lauric acid is important. Lauric acid 56th point in control, and after us, after US, 50.2 now. So any other acids also here. This is the first data. It is unpublished data yet. This is the one month before we found is the important. So thermal treatment, we use the fat globules of coconut here, and ultrasound after 10 minutes here, and ultrasound after 10 minutes here. Better homogenization we gave, and better homogenization we took, and also appearance and the consistency was very good. So lauric acid, have been blocked the colon cancer cells and preserved the oxidation stress of cell. So it is important that this is the it's using in the cancer chemotherapy lauric acid standards. So after ultrasound technology, we gained two-fold increasing in lauric acid. So it is important results. According to the ultrasound application and ultrasound duration, maybe we in retention times, or maybe change any other systems. So we may gain more concentration of the lauric acid, I think. So at this point it is important, because lauric acid have been blocked the colon cancer CSO2 and preserved the oxidation stress of the cells. So here coconut oil and milk also we study again. Yes, coconut oil fatty acids, and then after coconut oil fatty acid after ultrasound, as you see. So now any other applications or any other systems in my CRC press, Taylor and Francis book, fruit and cereal bioactives, and any other applications and last issues in my improving food quality of novel food processing techniques book this year. Also the others in international congress books. So now food byproduct based functional food powders book also includes other data. This data contain last innovative treatments but byproduct treatments also in forthcoming, I have to say. So thank you attentions. So see you next conference in Istanbul. It will be announced soon to you. So we are waiting to at Istanbul. Okay, thank you.